today we are going to see an important topic, IO interfacing module. Okay, it is coming under Unit 4 in Computer Architecture and Organization. And the course outcome for this particular topic is it uses the interfacing technique for programmable peripheral devices to enhance the input output operations in computer system. Already we saw about the input output module, which connects the input output devices, that is the peripheral devices, with our microprocessor, and how the IO functions, IO module functions we have saw. And this particular thing, that is IO interfacing module, which enhance the input output operations in the computer system. So let us see about this particular thing. So here we are going to see the two important chip, that is 8255 and 8251, which helps us to interact or communicate with the input output devices with the microprocessor. So this first 8255, which is like a peripheral interface, how it enhance the IO operations. And this 8251, we are going to see about how the data which will be transmitted between the microprocessor and the IO devices in a serial mode and parallel mode, and how this conversion takes place and so on. We are going to see in detail in 8251. So this is about these two important chips, how it enhance the work of the IO operations with our microprocessor. So first we will see about the microprocessor system, which cannot operate alone. They require input output devices such as keyboard, displays, printer, and sensors. These are all some of the peripheral devices which connect with the microprocessor. And to communicate with these devices, IO interfacing, that is ICs, are used. Okay, so that only we are going to see here. And then mainly we are going to see here is 8255, that is programmable peripheral interface. And then 8251, that is USAT, that is universal synchronous and asynchronous and receiver transmitter. So we will see about this in detail in the session. Okay. So first let us go and see about 8255, that is programmable peripheral interface. Okay. So here the definition of this particular chip is a programmable device, and it is used to interface the peripheral devices with microprocessor. So mainly it provides the 24 programmable IO pins, which is divided into three ports, that is port A, port B, and port C. So each port has 8 bits. That is, if you say port A means PA 0 to PA7, and port B 8 bits means that is a PB0 to PB7, and port C, that is we will divide into upper and lower, in which we will say like a PC4 to PC7 will be call it as like upper pins of port C, and then port C0, port C to port C3, which will be called it as like a lower pins of port C. Okay, so we will group, okay, with the A and C and B and C. How we will do it? Just we will see about the block architecture so that you will clearly understand. We will categorize into two groups, that is group A and group B, in which group A, which has port A and port C upper, and the group B, which has port B lower and port B. Okay, sorry, port C lower and port B. Okay, so this is about the group B. Okay, and this is how we will categorize into two group, that is group A and group B. Okay, so let us see about how this data bus buffer, okay, which will be connecting the internal bus with the system data bus, which transfers the data and the control words. Okay, we will have the read write control logic as we saw in the previous chips. In the same way, here also we have a read and write operation, and the A1 and A0, which will be the address lines to select this particular mode. We will see it in detail in the coming slides, how we will select the A0 and A1 based on the port, okay, which group will be selected and how these ports will be selected. We will see using this address lines A0 and A1. And also we have reset. Okay, that is for completely reset the complete chip logic. and then we will have like a chip select, in which how we can activate the whole chip. Okay, so enhancing the chip by using the chip select selection. Okay, and these are all the things about the thing. And group A, and which has, as I told you, port A and upper port C. Okay, and then group B, which has port B, that is complete PB0 to PB7, and lower port, that is PC0 to PC3. So that is how we will categorize it. And we basically we have three modes in which the port okay, A, B, C will be activated. In which mode 0, okay, so that means we will say it is like a basic IO mode. Okay, so here like 0 or 1, in which how the switch will be takes place. 1 means on and off means we will say it as like 0, right? Similarly for LED control, if it is 1 means LED display will be on, and if it is 0 means LED display will be off. Likewise, if you are basic IO mode, we will call it as like a mode 0. Coming to mode 1, that is, we will call it as like a strobed IO mode. Yeah, for example, it will wait for the request, and then the device will send the acknowledgement. And if the device is ready, that time the data transfer takes place. For example, printer, when you press a key, okay, so that is the time the processor have to be free in taking the device, okay, input device, and then it should activate it, and then the data will be transferred and it will be displayed. So similarly, keyboard, printer, the printer should be ready to send the data and scan the images which is present inside, and then it will be printed. So this is like ready state, checking for the ready state, getting the acknowledgement, and uh, uh, the the process will be continued. This type of mode we will call it as like strobed IO mode. Okay, and coming to the third one, that is mode 2, that is bidirectional mode, in which the transmission of data and the receiving of data will takes place. Normally in the networking mode, how we are connecting with the many system, and how the data will be transferred in both directions. That is, we will call it as in data communication. So as a whole, we can say it as like 8255 pin configuration. How you can define, as we discussed about the PA0 to PA, okay, 7, which is there. So PA0 to PA7. This is in the upper part of the pin configuration. You will have like a port A. Similarly, port B, that is from 18 to 25. Okay, so here we will call it as like PB0 to PB7. Okay, that is the lower part of the pin configuration. We will concentrate for port B. Similarly, for port C in the middle, that is 15 to 17. That is 14 to 17. That is lower pin port C. Okay, pins, that is PC0 to PC3, that is port C 3. And similarly, here we will call it as like, so PC4 to PC7. Okay, that is in the 14 to 11. Okay, so that is 10. We will have it as like port C. Got it? So this is how we will categorize the port C as upper and lower, and port B and port A. This itself has 24 pins. Okay, so dominating the 40 pin configuration. The other thing is for address lines A1 and A0, that is 8 and 9, and ground for earth, chip select for activating the pin. Okay, that is the thing. And read for reading the data, and similarly write for writing the data, reset the whole chip configuration to be reset. Okay, and any other pin which is missed? Okay, I hope we have covered all the pins, right? Okay, so VCC, that is for the okay. So for these are all some of the pin configuration we have discussed, as the expansion is also given here. Okay, for your understanding. Okay, so this is how we have used this 8255. Okay, and then also how the chip, the port will be selected. Okay, so that also we should be very clear with chip select. So that is we will say it as like bar. So automatically the chip select will be, when it is low, then it will be activated. If it is when the value is high, means that is inactive. That's why we have used the chip select bar. Okay, so 0 means it is active, 1 means it is inactive. Okay, so 0 means it is selected something. So A1 and A0 value. So if it is 0, 0 means port A is selected. And then 0, 1 means port B is selected. A1, A0, that is 1, 0 means port C is selected. Both are 1 means control register is selected. If the chip select is 1 means it is deactivated. So it is not selected. So we can say 8255 is not selected. This is how the address lines will be okay based on the different ports. And now we will see about already we saw about group A, that is PA and PC upper, and PB, that is port B and port C lower. Okay, so that is how group A and group B is categorized. And also it these three ports which supports three modes, as we discussed about three modes in the before the configuration, that is basic IO mode, strobed IO mode, and bidirectional mode. Okay, so which are all the port which supports which mode? Okay, so that only we are just explaining here. Okay, so port A which supports all the modes, mode 0, mode 1, and mode 2, and port B which okay, so programmed in only mode 0 and mode 1, and the port C which will be programmed only in mode 0 alone. Okay, that is the basic operation alone port C will do, right? So this is how we will check how the ports, different ports which will programmed in three different modes. Okay, so this is how in data buffer, in which the different ports which will be transferring the data. See, for example, if it is a group B means, as you know, group B means you have a port C lower and port B, right? Okay, so here you will have like 1 means input is taking place, and O means 0 means it is output. Okay, that is the port C lower. So D0 is designated for port C. Similar port C lower, and the D2 which is D1 which is designated only for port B. Okay, that is PB0 to PB7. Okay, so that is 1 means input and 0 means output. Similarly, here only these two ports, so we can say mode selection 0 or 1. Similarly, for group A, port C upper and port A. Okay, so that is we will see it as like D3 and D4. But here, D5 and D6, that is mode selection. Here it supports all the modes, that is mode 0, mode 1, and mode 2. That's why we have designated two different data pins, that is D5 and D6, for selecting either mode 0 or mode 1 or mode 2. Mode 0 means both are 0. Mode 1 means 0, 1, and mode 2 means 1x. Okay, so the first one should be x, and the second thing should be deactivated. Got it? That is called mode 2. Okay, this is for selecting the three modes for the group A. Okay, because it supports all the three modes. Here it supports only two modes. That's why we have 0 and 1 alone. Okay, so here three modes. So we are having three different okay selection mode selection. Okay, and finally we will say it as like a D7 as mode set flag, which is one which is active. If D7 0 means it is inactive. Okay, so that is how we are mode definition formats. Okay, so this is the thing we are here. Okay, so how these things are happening. Okay, so this is how D0 to D7 will be done. Okay, so this actually shows how this 8-bit control word, okay, is used to configure the operation of port A, port B, and port C in the 8255. Okay, so this is how it will be done. Okay, so this is the next thing, that is 8251, that is USAT. Okay, so till now we have seen about the U2 8255. Okay, so next we will see about the USAT. Okay, So I hope you understood very clearly. And in the next video, we will see about 851. That is, you said that is universal synchronous, okay, asynchronous receiver and transmitter. Okay, I hope you got it. Thank you.